welcome to another AQA AX Chemistry video. This is going to be a questions, or at least it's going to be past paper questions on oxidation, reduction, and redox equations. I've done the redox part of it, now that was done quickly. And I've got one question that's based on equilibrium. I tried to find the one that's kind of a bit closer to what it's like in a real exam. So, yeah, let's go for it. So, first question is, so I'm gonna start a timer. So 25 minutes, which I'm gonna try and do in 25 minutes. So I'll leave a link in the description for the questions here. So if you ever want to do it with me, if you want to do it by yourself, I suggest try and do it by yourself first. And then if you want to come look at this, how I done it, then yeah, I guess that could be helpful for you. So let me set a time for 25 minutes. I think I could probably do this in 25 minutes, but let's go. Right. 3, 2, 1, go. Alright. So in terms of electrons, the meaning of the term oxidizing agent, in terms of electrons, it would be if it's getting oxidizing, it means it's getting reduced, so it's an electron acceptor. I say it's an electron. Yeah, makes an actual sentence. Alright. So dichromate, the dichromate ion can oxidize SO32- in acidic conditions to form Cl3 plus and SO42 minus. To use a half equation for the oxidation of SO32 minus to SO40 minus. To use a half equation for the reduction of Cl2O72 minus to Cl3 plus. And use the overall equation for the oxidation of SO32 minus plus by Cl2O72 minus. So I probably should have went into more detail about how to actually solve half equations, but generally that's the GCSE thing, innit? But I'll go for it right now. But anyway, I'll try and explain it right now if you don't know how to do it. So I'll write down this part here, SO32 minus, right? And we know it's gonna form SO42 minus, right? How do I get from here to here? I've gained H2O, so I've gained an oxygen, but I can only gain an oxygen by H2O, so plus H2O. And now I have two H pluses here. Because I have two hydrogens now, 2H plus. So 2 minus, that's a 2 negative charge. Oxidation, okay, it's an oxidation reaction. We know it's an oxidation reaction, so it's losing electrons. So I'd say 2E minus here, but you can even tell anyway to make sure it's a negative charge on this side. This is a 2 minus on this side, and this is a net 0 because the 2H pluses and 2 minuses. So then the 2 electrons make it negative 2 minus charge for the oxidation because it's losing electrons. This is a reduction, so from dichromate, right? Dichromate ion Cl2O7 2 minus, and you're forming a Cr3 plus. So you know you have 7 H2Os because you have 7 oxygens here. That's 14 H plus, so plus 14 H plus. But then we need to also make sure that it's balanced here in terms of charge. So how to balance the charge? You have 3 plus here, and this would be overall 12 plus. 12, yes, 12 plus here, 3 plus here. Am I missing something? Oh, so 2 actually no. It's 2 Cl3 plus because it's 2 dichromate, so that should be 6 plus. And they go from 6 to 12, then you need 6 electrons, so plus 6E minus. Yes, yeah. And now the overall equation, I do it here first. So I look at, first of all, I need to make sure, if I was doing the overall equation of these two, right? Also, it's a reduction reaction, so it's gaining electrons, right? First of all, I need to make sure the electrons have the same number of electrons on both sides. So there's 2 on this side and 6 on this side. Also, by the way, I've noticed that, remember, there's electrons on one side of the equation, electrons on the other side. Make sure that that's the case. Otherwise, it won't. You made a mistake and it doesn't work. So anyway, we need to have the same number of electrons on both sides of the equation. So I have SO3 2 minus. We need to times this. Essentially, I would times this by 3, because that gets you to 6 electrons, and that's also 6 electrons. So I just times this one by 3, and that's just, so it'll be 3 SO3 2 minus plus 3 H2O plus Cr2O7 2 minus just say plus 14H plus for now, and then the electrons we don't take into consideration here because they're already balanced. It'd be 3 SO4 2 minus plus 6H plus and plus 7H2O. Right. So we cancel out the 3H2O on this side. So we have 3 less on this side. So 4H2O here. And then we can cancel out this 6H plus on this side. Take away 6 on this side. 8H plus. And that's all it is. 3 SO3 2 minus plus Cr2. Oh, I forgot to write this, the 2 Cr3 plus actually. Plus Cr2O7 2 minus goes out plus 8H plus goes to form 3 SO4 2 minus plus 2 Cr3 plus 4H2O. Alright, so which compound contains chlorine atoms with an oxidation state of +4? +4, that's easily this one. You can already tell. X minus 4, 0, X equal to +4. Some of these you can just see. If you didn't get that back, leave a comment in the video and I'll try to explain it again, but I think I tried to make that as clear as possible. So NO2 minus can be, I'm trying to do this in time conditions as well, so NO2 minus can be reduced in acidic conditions to NO. How many electrons are gained when each NO2 minus is reduced? So how to reduce to that? So we're going from essentially how many electrons are gained when we're going from -1 to essentially 0, right? Reducing acidic, how many electrons are gained? X minus 4 equals -1. X plus 3. X minus 2 equals 0. X is equal to +2. Is going from +3. Is the oxidation state on the nitrogen is going from +3 to +2. So it's gained. So it's -1. So it's gained an electron. Always look at the oxidation state of the nitrogen because that's going to be determining. In this case, because the electrons gained for the nitrogen. That's what you're looking at, the nitrogen. So which compound contains chlorine in an oxidation state of +1? I mean, I'll be looking at this one here really. I mean, 1. You can just kind of see which ones look like they'll be the right one. -6 equals 0. No, that'd be +5. Oh no, this one would definitely be it. 2x minus 2 equals 0. 2x equals to 2, and you know, but that's easy there. In which conversion is the metal reduced? I'm just trying to do is explain to you and do this in time conditions because I can see it, but trying to explain it to some people as well. So, in which conversion is metal reduced? I'm pretty sure that's a reduction. Let me see this. So, x minus 6 equals to -1. X. I know that's from +6 to +6, so it won't make a difference if you notice this reaction. And that's equal to +5. X minus x minus, x minus 2 equals to plus 2. If it's being reduced, it means it's gaining electrons, so it should become more negatively charged. X equal to plus 4, plus 5 to plus, Except, which equation doesn't represent a redox reaction? It's going from 0 to x minus 2, 0, so it's not going to be that. The hydrogen might go from plus, no, that's going from x minus 1 equals 0. No, but that's still going to be that, that's different. Maybe look at this here. Oh, this is definitely it. Yeah, there, done. I can see, because that's not x minus 2, and that's just going to be x minus 2 as well here, so no, that's it. Which VO2-5 can be used as a catalyst in the contact process? Which step is a step that the contact process in which vanadium is oxidized? I mean, I already know that. I'm pretty certain I just know it's this one, but let me just double check anyway. X minus 4 was 2x minus 4. 2x minus 8. So then essentially x is equal to plus 4. I'm pretty sure 2x minus 10, x is equal to plus 5. It's being oxidized because it's, it's lost an electron here. Which of these is a redox reaction? This is going from 0 to, I think it's plus, self is plus 6, right? X plus 6. That's going from, and you know it's going to be plus 2. That's easily a redox reaction, right? Some of these are just simply can be seen. I'm pretty sure that's the right answer for that. I'll go through the mark scheme at the end, by the way. I'm just doing it, trying to show you how you do this. But anyway, which of these species is the best reducing agent? Okay, so this requires knowledge of understanding the size of compounds and how. So reducing agent it means it's easily oxidized because it's reducing other things. This is clearly going down in the group, and as you go down group 7, the size of the atom increases, atomic radius increases, and the electrostatic attraction also decreases. I'll go through it in the next topic as well, but essentially it would be I minus easily, because going down the group, you're going, as you go down the group, the size of iodine would increase, and there's a weak electrostatic attraction, so it loses that electron much more easily, and also it's a negatively charged ion as well, so it's got that extra electron, so it's much easier for it to lose an electron there. In which reaction is metal oxidized? The metal here is going from 0 to essentially x minus 6. I thought, what did I do for the last one? I think, is it plus 6 or minus 6 for, I think it might be, I think it's plus 6. Right, I thought what sulfur is equals 0. Might be x minus 6 though. I'll come back to this one. I'm just trying to make sure I have enough time for. In which reaction is hydrogen acting as an oxidizing agent? If it's oxidizing agent, it means it's getting reduced, which means it becomes more negative. X minus 1, nope. 0 to plus 3x, 0, 3x minus 5, 3x equals to minus 5, x equals to minus 5 over 3. I feel like that's a weird one. This is easy, so 0, x plus 1 equals, and then 0, then that's the minus 1, so that's going to be easily there. I'll come back to that one, I'll come back later to it. Which of these following shows chlorine in its correct oxidation state in the compound shown? Chlorine. It will be, so if that's x plus 1 equals 0, x equal to minus 1. I just cancel some of these out, so you know that's going to be this one and this one are impossible. Cancel that one out, cancel that one out. That's the same, so that's not going to show any change. This is the only one I can show to change. 1 plus x minus 6 equals 0. That's minus 5. X minus 5 equals 0 plus 5. So you know it's going to be plus 5. That's it. Which is nitrogen in its correct oxidation state? So x plus 3, 0, x equal to minus 3. So then you can cancel out that and that. You know it's going to need that and that. So that's the same. So this is the only one that makes different. So x plus 1 minus 4, 0, x equal to minus, no, x minus 3, so it means this equal to 0, x equal to plus 3. Yes, so that's it. Which of these is not a redox reaction? Okay. So which of these is not a redox reaction? C2O. I'm trying to see if there's just anyone that says not. This one isn't. That can't be. That's x minus 2 and then x minus 2 here. I might have got this horribly wrong, but I'm gonna just get this is how I just go through them. I know I have to go back. So this is the equilibrium question. So nitrogen monoxide reacts with chlorine to form nitrosyl chloride or NaCl. 2NO plus CO2 goes form NaCl. Oh, what's this guy use? Alright, 1.50 moles of nitrogen oxide are mixed with 1 mole of CO2, and the mixture is left to reach equilibrium at a given temperature. The equilibrium mixture contains 0.350 moles of NaCl, and calculate the amount in moles of nitrogen of NO and CO2 in the equilibrium mixture. So let's just do an ice table. We have 0.35 moles of NaCl, right? And then we start off with 0, so it's gained plus 0.35. We know this is 2:2 mole ratio or 1:1, so that'd be minus 0.35 from 1.5. We're starting off with 1.5 here. 1 mole. There's 1.5 moles of NO and 1 mole of CO2. So 1.5 minus 0.35 is 1.15. Yes, 1.15. So that's really now known as 1.15, and this is a 2:1 mole ratio, 1:2 mole ratio. So that's actually, this is double what we'd expect. So it's actually going to be minus a half of 0.35. So 1 minus a half of 0.35. So 1 minus 0.5 by 0.35, and that would give us 0.825. 0.825, and that's it. Give the expression of the equilibrium constant Kc for the reaction between the nitrogen monoxide and chlorine to form nitrosyl chloride. We already know how to do that, and that's just, remember, it's products, square brackets, remember, it's our products over reactants, NaCl, and the molar ratio represents the exponent. So it's NaCl squared over NO squared multiplied by Cl2. And that's it. For Kc, that's how we represent them. For Kp, we represent it slightly differently. But we haven't done Kp yet, so don't worry about that. A different equilibrium mixture is prepared in a flask of volume 800 centimeters cubed at a different temperature At equilibrium, this mixture contains 0.85 moles of NO and 0.458 moles of CO2. For the reaction at this temperature, Kc is equal to 1.32 times 10 to the power minus 2 moles per dm cubed to determine the amount in moles of NaCl in this equilibrium mixture. So we have to rearrange our Kc expression to work out NaCl specifically, and so I can just do that. So NaCl is equal to, we know it's the square root over, I'm trying to do this in exam conditions, so I'm not going to, I've already explained in previous videos how to do that. I'll probably leave a link in the description. But it's going to be Kc times by NO squared times by CO2 in that. So Kc times by NO squared times by Cl2. And that is our, that's how we work it out there. We would need to work out the concentration. Do we have the same? No, it's not the same. There's not the same number of moles on the reactants and products. It's 3 to 2. So we'd have to work out the concentration. So NO2 equal to, do I say NO2? Do I say, no. I just say just NO is equal to 0.85 because concentration is equal to moles over the volume. 0.85 over the volume, which is 0.8 decimeters cubed, or 800 over 1,000. So 0.85 over 0.8, 1.0625. How much time have we got left? 4 minutes 25 seconds. Alright, it's fine. The moles of Cl2, so not moles, sorry, the concentration of CO2 and the concentration of the NO. So concentration of CO2 is 0.458. 3 significant figures, sorry about that. 3 significant figures, guys. Over, maybe you should also write 800 over 1,000, just in case they do want to say that, to show you how you got 0.8. But the examiner should be able to tell that what you mean by 0.8, but still, I'd say still, that should be -3. Still write down this little thing here. Anyway, so 0.458 over 0.8 decimeters cubed. 0.458 over 0.8 decimeters cubed, and that's equal to 0.5725. Yes, 25. Concentration of the NaCl is equal to the square root of 1.32 times 10 to the power minus 2 times by 1.0625 squared multiplied by 0.5725. Yes. 1.32 times 10 to the power of minus 2. 1.0625 squared times by our last answer, and that is 0.0924 moles per dm cubed. But remember, they said in moles, the amount in moles. So then it would be, so if concentration equal to moles of volume, moles equal to concentration times by volume. So moles of NaCl, how much time have you got left? 2 minutes and 5 seconds. Moles of NaCl is equal to 0.0924 multiplied by 0.8, and you should get 0.0739 moles, or 7.39 times 10 to the power of minus 2 moles. This means the same thing anyway. When 1 mole of ammonia is heated to a given temperature, 50% of it is dissociated, and the following equilibrium is established. What is the total amount in moles of gas in this equilibrium mixture? Well, we've worked out the total moles first. So it's 1, so 1.5 plus a half, that's 2, then plus 1 again, that's 3. But it's, remember, 50% of it ends up is dissociated, so we only have, the total moles is 3, but then in equilibrium it's half of that, so that's 1.5. Okay, now we go back to that question that I missed out on. This one here, where did I go? Was it? I think it was. I'm actually so blind. Yeah, sorry, my bad. Just trying to create more space here. All right, 29 seconds. I look at this. I think it's X minus 6, right? The metal is oxidized, so it's losing electrons. So it's going from 0. I think it's X minus 6. Yes, so then it goes from 0, that's plus 6. X is equal to plus 6, and that's it. There you go. 25 minutes. I should have done it in less than 25 minutes, but I have to try and explain. So, I'm gonna try. Okay. Let me go get the mark scheme first, and then see how we did. So I just need to set this here. Alright, so this is the site we find it from though, right? So I just need to get this back up again. Would have been this one. Yes. Yeah, I think this is right. So let me see if you can see the whole thing. You know, I'll just read out what it says, and then I'll read out what it says, and then if there's anything, I'll bring it back and then so you can just see it here. So electron acceptor, so it's an electron acceptor, that's fine. SO3 2 minus plus H2O goes to form SO4 2 minus plus 2H plus 2 minus. Cr2 O7 2 minus plus 14H plus 6E minus goes to form 2Cr3 plus 7H2O. 3SO3 2 minus plus Cr2 O7 2 minus plus 8H plus goes to form 3SO4 2 minus plus 2Cr plus 4H2O. I've already explained how to do these things. I'm not going to kind of go over them again, but if you really didn't understand this part, go to the video where I explained how to do these. But yeah, as I said before, you want to make sure there's the same number of electrons. When I'm looking at the overall equations, right, the very first thing I'm looking at when you're doing this is make sure that there's electrons on the right side, they're not on the same side. That would mean that this would be wrong if it was on the same, if the electrons was on this side. Remember, it's a reduction, right? So the electrons are on the other side. That's the first thing. That's good, right? I say this because when you do electron potentials, you need to make sure that your electrons are on the right side because they're all in the side of reduction. But they're on the right side. Do they have the same number? No. There's 6 electrons in this equation. There's 2 electrons in this equation. How do I make them the same? Times this one by 3, and they both have 6 electrons, right? And then sometimes if you have to times them both to make sure to get the same number, then do that. But the easiest way is just times this by 3. Easiest way. Once that's happened, you then cancel out. Once you then put those equations together, right? So you times that by 3, but then you have to cancel out any additional H pluses or because you see in this one here, you're forming 14H plus in total in the 14H plus in your reactants, but then you have 6H pluses in your products. Take away that 6H plus there, so in total you just have the 8H plus that you actually need. The same thing with the water. You have what 3H2s in 3H2Os in your reactants and 4H2Os in your products. Sorry, it was 7H2Os in your products. Cancel that out, you form overall 4H2Os. Ideally, you want to get that net. And after that, you're just adding everything else in. And obviously, make sure you balance your equations correctly. And yeah, that's it really. And I've already explained that. I think that's pretty self-explanatory. But again, as I said before, if you still struggle with this, leave a comment in the video, or just if I'm talking way too much right now, just skip to the next part of the video, next part of the part of the video that you need. But anyway, that's 4 marks here. Question 2 is C. I'm just gonna go see what the answers are and see if we get anything wrong. A. 4 is so A D D C A D D C. Wait, did I say that wrong? A D. Yeah, C. 8 was D. 9 is D. 10 is D as well. 9D, 10D, 11D. Yes, so these are all correct. 12 is C. 13B. 14 is B. I didn't even mark for that, that's B. So far so good, we're going 100% so far. Now this is a separate part of it, so I have to go back and the physics and math sheet is a good place to go and get exam questions. Whilst I'm doing that, I'm going to explain. So yeah, physics and math sheet I'm not sponsored by the video, but yes, physics and math sheet is just a great place to go and get past papers. However, if in my experience, I think the questions they're good if you need to master them. But once you've mastered these questions, don't get into the mindset of these questions are really easy. I'm gonna smash through the exam. Try and find some actual there are exam questions, but now do a past paper, because they're not always as easy as the real past paper. So I get an actual past paper if you're finding the questions of physics and math sheets quite easy. Okay, now I finally have it now. That was question 8, 5, 6, 7, 8. Yes, so that's 1.15, 0.825. NaCl squared, NO squared, CO2. Yes, that's fine, no problem. Alright, so next part, you get a mark for M1 is for dividing the moles by quantities to get 0.8. So basically, doing this, just this little section here, that essentially, and then rearranging it, you pretty much, if you just divide your moles to get by 0.8, that's 1 mole. That's 1 mark. NaCl squared equals 8.53 times 10 to the power minus 3. Was that? And you get the second one for just evaluating NaCl squared. So, what do you mean by? I'm trying to see what they mean here. Yes. Yes, here. Sorry. If you get this, if you didn't do the square root of this, right? I just did it in one go because I know how to rearrange equations, right? But let's say this was NaCl squared, right? And then you just times 1.32 times 10 to the power minus 2 by 1.0625 squared times by 0.5725, you'd get 8.53 times 10 to the power minus 3. This is what it says on the mark scheme, right? You'd get that, but it says evaluate, showing you get the second one for just showing that you've evaluated NaCl squared, and that's basically what you've done. I would do it like that. That's as the mark scheme, doing this, finding out that it's 8.53 times 10 to the power minus 3 moles squared dm to the power minus 6, and then square root it. But ideally, if you've shown, because the mark after that is for square rooting your M2, right? And I've basically if you've done this part times by that. Well, 1.065 squared. If you type that's basically the same as your 8.53 times 10 to the power minus 3, and your M3 is just square rooting your M2. So from what I've understood, that would be, I've already done M3 and M2 in one calculation. But as I said before, talk to your teacher and do it exactly in the way of the mark scheme. It's step by step. I've just seen the space. I've just seen I could just do it in one process, so you can do that. But the examiners are very, they're very how can I say, stingy, so they might just get onto you for that. But you do get a mark for saying 0.0924 moles per dm cubed So that is where the mark would be. Actually, I should probably, that's not right there. That's one mark there, one mark there. And then converting the moles, 0.924 times 0.8 to get 0.0793 moles. And that's your answer there. So you can write it like that, or you can write it in standard form, 7.39 10 to the power minus 2, or 0.0739 moles. 1, 2, 3, 4. I've got the previous ones correct as well. Number 9, 1.5. Yeah, that's it. Hopefully this video was helpful.